the triangle. It's one of the most interesting shapes in mathematics and also one of the strongest and a foundational piece of so many things. So how do we define a triangle? Well, a triangle is a three-sided figure or a three-sided polygon. When we think about a triangle and its pieces and its name, a triangle has vertices, namely the corners. So the vertices of a triangle, in this case, are A, B, and C. And that's how we name a triangle. We can name this triangle A, B, C. Now, in a triangle has also three segments that make up its sides. So the sides of this triangle are segment AB, segment AC, and segment BC. Within each triangle are three angles. And we're going to study the properties of those angles and sides as we go. So the angles, yes, we can name the angles angle A, angle B, and angle C, but let's practice for a moment. This angle down here would be angle ABC or CBA. The angle up top could be angle CAB, and the angle down below could be called angle BCA. So triangle, a three-sided polygon named with its vertices. It has three sides and three angles. When we classify triangles, we can classify them in different ways. And so that's what we're going to look at next. So we're going to look at the classification of triangles by its sides. So the first way we can classify a triangle by its sides is we have what's known as a scalene triangle. What we know about a scalene triangle, it has no congruent sides or angles. Now, the markings that we're going to use are going to show that. So I'm going to make a triangle that has no sides the same and no angles the same. Now I can mark off the sides using marks. So that side of the triangle is going to have one mark. Another side is going to have two. And the bottom will have three. Now the markings on a triangle classify with the arcs or go across. So since we have one mark, the opposite angle, we can say has one arc. Opposite the two marks on the right side, we can put two arcs. And then opposite the bottom, we can put three arcs. The arc markings and the mark markings, that's a lot to say, show that the triangle doesn't have any congruent sides or any congruent angles because the markings of both the sides and the angles are indeed different. The second way we can classify triangles is a fun word to spell and maybe say for the first time if you've never seen it, and that is isosceles. Isosceles triangles have two congruent sides and thus two congruent angles. if I make an isosceles triangle, and the way I've drawn it, I'm going to make the two sides left and right the same, and the bottom to be different. Now, if we consider the arcs across from the marks that are the same or congruent, then the bottom two angles have to be the same. And it would be the top angle across from the side that's different that would have a different angle measure. That's an isosceles triangle. Now, in a triangle that's isosceles, these two angles right here, I know they're on the bottom, but the congruent angles in an isosceles triangle are called the base angles. Let's go and take a look at our last classification by sides. And that is equilateral. The prefix is EQUI, and that means that it has three congruent sides, or all sides congruent, and three congruent angles. If we drew this, all the sides have to have the same marks. So we can put one mark on each side. It's also going to mean that each angle has to be the same as well. So scaling, no congruent sides or angles. Isosceles, two congruent sides and two congruent angles. Equilateral, three congruent sides and three congruent angles. Now, I'm going to go back to the isosceles triangle for a moment. That an isosceles triangle has two legs, and those legs happen to be the same. This side that's different is actually called a base, hence the base angles down below. This angle up top has a name. We don't refer to these very often, but it's called the vertex angle. Now, I want to classify triangles next by their angles. So let's look at that. The classifications of triangles by angles this time. And there's going to be four of those. First of all, an acute triangle. If we think about acute angles, acute triangles have all angles are less than 90 degrees. We could draw one, and it might look something like that. Second, we have what's known as a right triangle. This is where one angle equals 90 degrees. And we show that using a box right here. Third is an obtuse triangle. This is when we have one angle that is greater than 90 degrees. So we have a big angle somewhere inside the triangle. Finally, number 4. And this is a equiangular triangle. This is where all angles are congruent, just like equilateral. So we could show that by marking off all the sides, or all the angles, excuse me, to be the same. Now, a little bit of a side note here, and it's a theorem, and we can prove it. And what we know is that the sum of the interior angles in a triangle is 180 degrees. That's why we can only have one right angle in a right triangle. That's why we can only have one angle that's bigger than 90 in a triangle. We can also figure out the degree measure in an equiangular triangle. Now, for your information, I'm going to show you why the angles in a triangle add up to 180. I'm just going to show you a proof here. We're going to take two parallel lines, and I'm going to build a triangle between. And I'm going to put angle 1 down here, and let's put a 2, a 3, and here's an angle 4, and here's an angle 5. If I were to prove that the triangles are congruent, so first of all, I could say that, well, this is A is parallel to B. So let's say we're given A is parallel to B. Now, what we also know is in our picture that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. We could say that because those three angles together form we could say they form a line or a linear pair, but they are also, we could make a case that, hey, all of those have to add up to 180, don't they? Okay, so next what do we see? Well, we know that angle 1 and angle 4, if you look at this, they are alternate interior angles. So the measure of angle 1 equals the measure of angle 4 because alternate interior angles are congruent. And we also know that 5 and 3 are also alternate interior angles. So since angle 4 is the same as 1, we're going to replace angle 4 with angle 1. We still have angle 2 sitting here. And now we're going to replace angle 5 with angle 3. And that equals 180 by substitution. Well, what do we see? We see that angle 1, angle 2, and angle 3 are all inside of this triangle. Therefore, we come up with the rule. The sum of the interior angles in a triangle is 180 degrees. How about that?